So welcome to the first review video for the AP exam. I was hoping to do something a little bit more entertaining than this, but hey, then coronavirus came, and as it goes, life is pain. All right, so let's get started. This is a lot of the vocabulary from the Earth Systems unit that I want you to be aware of. Now, this is a really long and exhaustive list. This is everything we did in virtually all of Earth systems. And this includes soils, this includes atmosphere, this includes hydrosphere, so it includes weather, El Nino, the rock cycle, plate tectonics, everything. So I'm going to break each of these review videos up into certain segments, and we'll go from there. Let's start with the first one, which is this. The approximate age of the Earth. It's about 4.5 billion. So the Earth is about 4.5, if you want to be very specific, it's about 4.54 billion years old. That's about a couple 100 million years older than the sun, but it's about 4.5 billion years old. And then number 2 is a sample FRQ, and this one may look familiar. It was actually the first FRQ you did in your Earth Systems exam. So this we're actually going to do some practice on Google Classroom with, so we're not going to worry about it for now. But let's worry about this map. So it asks you to identify a few things. It asks you to identify areas that exhibit island arcs. It asks you to show me where a non-volcanic mountain chain is, and areas where new crust is being created in a divergent plate boundary. So let's go back to this map, and let's look at island arcs. So island arcs are chains of islands that appear along subduction zones. So anywhere where you have one plate going under another, so one plate subducts below another, right, in a subduction zone, you're going to have these island arcs. And they're formed because of a lot of pressure that builds up right around here, right? As this oceanic crust here is sinking below the continental crust here, or if the continental crust is rising above the oceanic crust, however you want to look at it, a lot of pressure is being built up because of all this material. And that is going to come up and create these volcanic island arcs. Let's take a look at where that's happening. So the island arcs are going to be very common along the Ring of Fire. So this is a picture of the Pacific Ocean, and you're going to get this Ring of Fire, as we call it. That's because you have a lot of tectonic activity happening here. You're going to have some island arcs. So virtually this entire chain of things here is an island arc. There's actually an island arc here off the coast of Australia. There's another island arc up here. So anytime you see these like long straight chains of volcanoes, right? If I had the full problem, all these dots are considered like volcanic activity. Anytime you have these areas where you see these long chains of tectonic activity, that's usually a hint that you're at a subduction boundary, and you're going to see quite a bit of island arcs there. Let's keep going. Number 2 asks you to find a mountain range that is caused by uplift. So that's actually happening in 2 places. Let's actually take a look at how these mountains form. So when you get 2 pieces of crust coming together, like they are here in this diagram here, you're going to get what's called fold mountains. So I don't think you need to know that term, but these are fold mountains. And fold mountains occur when you get 2 pieces of crust, 2 plates coming together, and they kind of uplift each other. That's kind of what causes mountains to form. And actually, this entire chain along here that I'm circling now, so this stuff here, those are all mountain ranges caused by this uplift thing. So up here in North America, you have the Rockies. And then down here in South America, you have the Andes. And both of these mountain chains are formed as a result of this uplift motion. Another thing you need to know is areas where new crust is being created due to divergent plate boundaries. So let's take a look at first a diagram of divergent. So when you have two plates and they're moving away from each other, so like we've got in this diagram here, we got one plate moving this way, you have another plate moving this way. Up here, it's going to open up an area where magma from underneath these plates can come up and cool off and become new crust, become new rock, right? So that's seafloor. So that's what happens at a divergent plate boundary. And that is going to happen here. And I'm going to draw this in a different color. Let's change this to maybe, you know what? I like green. Let's go with green. And everywhere where I'm drawing these green lines is where you're going to get a divergent plate boundary. I don't think you really need to know the names of these, but this giant plate here that I'm going to outline. So this is the Pacific plate. So this is a piece of oceanic crust. This is the Pacific plate. And the Pacific plate right now is moving kind of in this direction. So the Pacific plate is causing subduction here along this plate, and it's also what creates a transform boundary along the coast of North America. So the Pacific plate is kind of moving this way, and there's another plate here. I'm trying to remember. This is the Nazca plate, whatever. You don't need to know the names of the plates. But this plate is moving this way, which is creating a divergent boundary here, which is allowing new crust to come up. So right around there. I understand that this diagram is a little bit of a mess. Hopefully you're following along. Let's move on to the next one here. So here it asks you to explain what causes seasons to occur in temperate zones. And that's the tilt of the Earth, right? The tilt of the Earth is what creates the seasons. So the Earth is tilted at an angle, and for one half of the year, right, as we go around the sun, as we kind of go around the sun, during our summer, so in the northern hemisphere, our summer, the northern hemisphere is facing the sun. Now, as the Earth spins, the other half of the year, right, we are getting the southern hemisphere that gets more sun, and that's our winter. The northern hemisphere is getting less sun, so here we have winter. That's what causes seasons. Moving onward, it asks you to explain how solar insolation affects wind patterns and precipitation patterns. Well, insolation is, don't mistake that with insolation with a U. Insolation is solar energy, the amount of solar energy. So the amount of solar energy you get in each area is actually going to affect these updraft and downdraft cycles, right? So these are your convection cycles. And in the atmosphere, they're powered by the sun. So areas that get a lot of sunlight are going to warm the ground, right? The energy of the sun is going to be converted into thermal energy, and that thermal energy is going to radiate out of the ground and start warming the surrounding air. Warm air is less dense and it begins to rise. Warm air also holds a lot of moisture. So there is a lot of water inside moist air. As it rises and it starts to move, it's going to lose a lot of moisture up here. It's going to cause a little bit of rain. And by the time the air has cooled off and lost all of its moisture, you're going to get this downdraft area, right? Your downdraft. And that's your general convection cycle. Warm air rises, cold air sinks, and you create this movement of wind patterns. Well, globally, it looks a little bit more like this, right? This is where you're getting into your Hadley cells, your polar cells, and these big movements of air across the world. The equator gets the most light, the most solar energy throughout the entire year. So along the equator, you're going to have these massive updrafts along the equator. And those updrafts are causing all this warm, moist air to rise. And as this air starts to move globally across the world, right? Globally across the world here, it will begin to sink. And by the time it sinks near these 30-degree latitude lines, it loses all of its moisture and it's very dry air. So along the equator, you're going to get a lot of rain. And then in the 30-degree latitude line, where these giant cycles of air start to sink down, is where you're going to get your dry conditions, right? So that is where you expect to see your deserts. Same thing actually happens along here. During the summer, we get more sunlight in the northern hemisphere, right? And you're going to get these updrafts along the you're going to get these updrafts occurring somewhere near the temperate regions, which is going to cause seasonal rains to occur. Let's move on to the world atlas below. And let's label some of the following things. So, let's start with the equator. The equator I like to think of as cutting Africa into it cuts the bottom third of Africa off. So let's draw the equator as a red line. It kind of cuts the bottom half of Africa off. So the equator runs right around here. So this is your equator. I'm going to label that as 0 degrees, right? That's your equator. Then let's go ahead and label the Arctic Circle. The Arctic is up in the north, so the Arctic Circle is your North Pole. So this is your Arctic region. The Antarctic region is the South Pole, so that's going to be down here. In fact, for some reason, they don't even have Antarctica labeled, so this is going to be the Antarctic or Antarctica. The Tropic of Cancer is right around here. It's just below the 30-degree latitude line. Actually, let's draw that in a different color. Let's make that blue. So here in this blue line is your Tropic of Cancer. This other blue line is going to be your Tropic of Capricorn. And I like to think of the Tropic of Capricorn right around there. Okay, right around northern Australia. So there's your Tropic of Capricorn. It kind of cuts South America in half. Your polar regions are actually both the North Pole and the South Pole. So this is a polar region. The north half is a polar region as well. And now let's think about where you're going to get your temperate regions. So I'm actually go ahead and I'm going to highlight that. Your temperate regions are going to be massive, and temperate really means seasonal. So areas where you're going to get seasons. You're going to get seasons virtually above the entire Tropic of Cancer. So in all of this place, you'd expect some sort of seasonality. And then also right below the Tropic of Capricorn, here's where you'll expect some seasonality. If you go any farther south, so here, if you go any farther south, you're actually going to be in a polar region, right? If you go any farther north of the seasonal area, right around there, this is where you're going to get your polar region. Northern Hemisphere, Southern Hemisphere, that's kind of easy. All the major continents, you should know them, right? This is North America, this is South America, this is Europe, this is Africa, this is Asia, this is Australia, and this is Antarctica. It's also a continent. The only other thing I really want you to pay attention to is just know the different types of plate tectonics, right? Know what happens at a divergent plate boundary when plates move away from each other. Know what happens in a convergent plate boundary when plates collide with each other. And know what happens in a transform boundary as plates kind of slip side to side by each other, right? The transform, you'll expect a lot of earthquakes. Well, actually, you can get earthquakes with any of these. In convergent boundaries, right, you'd expect a trench. You'd expect volcanoes, all of that stuff. In a divergent boundary, you'd expect a ridge. You'd expect new crust. So just kind of review and make sure you understand how the different types of plate tectonics works. And of course, what drives these plate movements? Well, that's also a convection cycle. Reactions that occur in the core of the Earth release heat, which heats up magma, which causes it to rise and sink, and these plates are floating along these convection currents. And my max recording time is reached. Cheers.